Welcome to, or back to, Design 380. It's a video on how to generate a shaft shape out of components and some minor dimensions. We have four components here. I've downloaded these from KHK, who makes gears. They supply sketches. Be maybe not using, but for example the keyway might be interesting, along with step files. I've uploaded these into Fusion already. SKF has very nicely supplies step files of their bearings, which makes sense, and we're going to be using this NR, which is a you can see I downloaded two versions of this 6206. 2Z is two shields, and then two shields with NR is a retaining ring or snap ring on the outside race. This 6305 is just two shields. There's some documentation that comes with that. You can see that there's the ring in the bearing, and the next guy is just basic shape, standard bearing with shields. Looks just like that, little metal shields. They don't touch, so low friction, but they keep some chaff out of the machine, out of the bearing. They're modeled particularly well by SKF, as is the KHK bearing, so we're going to use them. We'll have to see what's going on. We'll also be later referencing over to some standards for keys. This is the DIN standard 6885 from just a supplier online. Notice there's two types, high type and low type. We have a general shape here, sizing. Ignore the highlights here, that's just Mac OS highlighting text. And we've got H and B, the breadth and the height rounded. Last but not least, and we won't be using it in this video, we also have the old school ASME standard for keys, but we'll not be using that for now. So that's what's going on. Let's get at her. Start with a sketch. I've already saved this part up above the components, so I've got this gear, shaft, and the components what we're looking inside of. Let's start a sketch. Doesn't matter what plane we use, it might lay out nicely if we pick parallel to the right. And as usual, lately, for some reason my grid disappears. Go to about 200. Draw a line. Escape out of that tool. This is going to be the center of our shaft, so give it a center line. We're going to do this in a slightly strange way. I'm trying to make a point. I'm going to be making a point today about how to use the components to drive the shape of the shaft. There will be a little bit of memory going on here to figure out dimensions. It's not so bad. It can be equation driven, but I think, and we'll get to it, you'll see what we're talking about when we get to it, but I want to make the point of how the shape of the guy, shape of the shaft, is driven by the components and the surrounding detailing. So there'll be a little bit of sort of strangeness, not standard calling for this. We do need to know the position. Now this is usually given from the outside system, so let's put some points on the center line, 2 on each end. We're going to be measuring kind of from both ends at once, and we'll give them some dimensions. 25, and then between that and the next point is 70. Same on each side. Now, I'm not going to do formula driven here, or make this equal to that sort of thing, because I might change these independently. So I'll make them all the same, but type them in all on their own. Notice this is fully defined now because of the 200. I might want to know this measurement. It'll turn into inspection because I've said, yeah, don't show me this warning anymore. So inspection is in the brackets. We might flip this back and forth with the 200 later. The goal is to be able to adjust these dimensions as we go and not have them fixed. So don't want to, for example, change the spacing between the where the bearing eventually will be and where the gear will eventually be, might be interested in decreasing the overall length of the guy, of the shaft. So that's where we're at. It's really tempting right now to just start placing. We don't know where to place, so we're going to try placing them just kind of in a rough fashion, and then draw a shaft underneath in this same sketch again, and then lock the components into place so they move with the sketch. That's the plan. So there's our midline, really boring looking. Let's have a look at the dimensions, so show dimensions. And I'll give this a name, layout, shaft. Always keeping in mind that we would like it to be fully defined. Let's place them one at a time. The order is going to be the 6305, the 15 tooth, then the 25 tooth, then this 6206, all in a row, starting at on our point here, the origin left side. So let's do that. All you have to do is insert into current design. You'll notice these have colors. That's my way of saying to myself that I went in and had a look at them. Right, you can, for example, show the bodies, have a look. It's all modeled in there. It's all one component just with a bunch of bodies inside. Nice. If you want, what I do is I just cycle the component colors. You can undo that. Once you save, you'll be able to see the colors in here, which just tells me that I've done something. So I went in to have a look, make sure everything's kosher. Insert into current design. Tends to come in as modeled. It's not exactly what we want. If we look down from above, it's in the middle. It's good. Let's just rotate it into kind of position and just look at it from the top, move it kind of into the right spot. I'm not going to get too carried away here. Actually, I don't want it to be right on top of that point because I want to use a joint. But we can just make sure it's looking okay. Do not ground the parent. Turn that off. This is usually triggered at the first place. For us, we're going to use a joint to move this later, so just turn that off if it is on. If you forget that, you can always turn it off in the browser later, so you can see where's it? Ground to parent up in here. Just a toggle. So just getting used to this. Next, the small gear, the 15 tooth. Insert in the current design. Look at it from above. Want it, the hub, the bare hub to the left for now. Put it kind of into place. Doesn't really matter where this is. Make sure it's not grounded. Say okay. So just kind of getting things set up here. The larger 25 tooth, insert. This, you'll see how much bigger this is here in a second. There we go. Rotate it into sort of orientation, and we want it, the bare hub pointing right this time. It's a fairly arbitrary decision on my part. It depends, obviously it's going to depend what the other components need in the shaft if we're doing this as an assembly. But for us, we'll just say, let's put the gears as close to the middle as possible. This will not be great for bending. But it can be designed around. So it's up to you. But for this video, if you're following along here, just put them in this configuration. Do not ground. Say okay. And last, the bigger bearing, or well, bigger bore, same outer diameter. So insert into current design. The 6206 with the ring. Go to home position so you can see what's going on. Now I want the ring to be out farther away from the center point of the shaft. This will let me, in the future, position it in a way that would let it lock into a housing. So a housing would be outboard of this, maybe a cap of some sort. So there we go. Kind of in position, say okay, not grounded. That's that. So let's also turn on an inspection section analysis. Flip it to the right side, say okay. Now we can see what we've got here. We see the shape already, right? We come in, a little bit of a step up, maybe a shoulder up in here, step down, and the end. So that's the plan. I'm actually going to do this now. And, you know, we can kind of adjust this. So can we put this last? So just manipulating the history here. So I'd like to be able to see these components while I adjust the sketch. Perfect. I'm going to close this data panel here so it's not in the way. And if you want to get even more minimal, you can shrink the browser. It's up to you. If you hover, it'll come back out. For now, let's just draw the sketch. Just gonna a little bit of minor tidying up here, get the dimensions out of the way. Leave that there. And now let's edit the sketch. Just right click. Everything should stay, we hope, and we see the sketch palette. So it gives an idea of what type of shape we should be looking at here. So, oh, mouse is a little tender. One over to here, somewhere in the middle, step, and save up here. Just try to avoid that finish the line tool thing. This is maybe a little bit bigger. We'll find out when we get there. In between. And we're almost there, closing it up. We can drag this into place if we wish. And you can see here that I've accidentally, this is not bad, I've accidentally created a constraint here. You see this? This is a projected geometry. You can just delete that if you want. We don't have anything constrained yet. So this is going to be a loop of positioning everything in place. First thing, we've got this dimension. We're going to use these shoulders to position the components. Let's go ahead and do that. I'm going to show the browser. I'm going to hide the components. Hide the components. You can either just turn off the eye, or you can shift select them and press V for visibility. Let's go for coincident. Now, what's going on here? Oh, put the wrong button. So we've got some, looks like someone's off. Okay, that's what's going on. So just keep an eye on your, this is perpendicular to what? Well, this line's not horizontal vertical, so let's make sure we get everything running properly. There we go. That's what we'd expect. Defined lines in place, but the ends are open. It's good. Finish the sketch. Usually when you do this, if you turn something off during the sketch, it'll just come back. Eventually, there we go. Oh, maybe not. Let's turn it back on. Now, if you want, you can pull this into shape, but for now, let's do a revolve. And there's only one thing active. It'll assume this. Should do the whole thing. Do a full sweep. New body is good. It'll show up in the bodies folder inside the upper component. Say okay. Its color red is controlled by the overall color of the assembly if you wish. And I'm, for some reason, getting all worried about this stuff lately. I'm going to go for a different color here. And this will just adjust the full, all the bodies in the shaft. I don't know about, yeah, it's kind of an ugly color. Blue, too dark. Green's okay, too dark. I'm actually, if you wonder what I'm looking at, I'm looking down here. It shows me the color there. This could take quite a while. What did we do in the video? We sat and watched Colin changing colors for endless amounts of time. Oh, yellow. So there's our shaft. Now it's kind of small. What you can do is, if you wish, you can start pulling it kind of into shape. get a feel for what's coming. So our sketch is undefined on these diameters, so we're getting a feel for this. Now, the problem is that we've just dragged these components into place without, like, willy-nilly, like without really knowing what's going on. So we need to be a little bit more thorough, obviously. But we also want to use the shaft to control the placement of the components. We also want to use the components to shape the shaft, if that makes sense. So we have this reiterative reentrant thing going on. How do we do that? Well, one way is to just go ahead here and do some joints. So let's do that. Well, notice here in the history we've got the 4 placed components, then the sketch, then the revolve. So we can't really go further back because we'll lose our shaft. So we need to use it as is. So beginning with, say, this bearing here, let's do some joints. I'm going to turn off the analysis altogether so I can see what's going on. And if I want, I can drag things around. It's sometimes easier to hide them as you go. So let's go ahead and use joints, J on the keyboard. I would pick this part at the top edge of the fillet on the inside race of the bearing. And because this is the unconstrained, you pick that first. And then the constrained, which is the shaft, locked into place by the sketch into the assembly. There's a choice here. You can either pick the inside, which is kind of where you think you should be, but we might put a fillet here later. We might then break our joint, so pick the top edge. Motion is rigid, position is as done. Angle, ignore that because we shifted that. If you want, for this, you could say 0, see what that does, nothing, right, because it's just a bearing. So it's up to you. Right now we've got an angle of 0, everything looks kosher. We'll say okay. I'm gonna hide that. Oh, I'm gonna not do that. I'm gonna hide that and do the next one. If you want, pull it out of the plate, out of the way. It won't remember where that is. Same argument as before. Up inside on the face, that's going to position the gear on the top of the chamfer and the back, the top edge of that shoulder. If you want, change the degree to. Oh, we don't want to do that because we want our. Well, maybe we do. You can see our keyway here is pointing down. Where is that? 0? Oh, it's minus 90. So maybe minus 90? No. Minus 180. There we go. That's what I want. I want the keyway pointing towards me in the positive Z. It'll just make our sketching easier later. So have it pointing out. Once you're happy, motion should be still rigid and say okay. Perfect. Do it again. Joint. Top of the chamfer, top of the shoulder. Go for probably the same, minus 180. There it is. Say okay. Now notice our diameters are not fixed yet, so there might be some strangeness going on. You know, we can do this. That's fine. This is going to be our memory game in a second here. Next and last. Joint. See. Top of the fillet. Top of the what's that thing called? Shoulder. Doesn't matter on the angle for this guy, 0 is fine. But for this, make sure, this is your chance to make sure that the key, or that's not a key, the ring, sorry, the ring is pointing outward. It should be away from the center of the shaft. This would be a way to tether our gear shaft into a housing later. So make sure that's pointing out. Say okay. Show them all. So we're still not fully defined here. We're going to do this old school without formulas or anything to make a point. There's ways around this, of course, parameters and all the rest, easy stuff. But for us, let's go ahead here and get this sorted out. The problem is, if we pull back, they all move, right? So this is before our joints. We have this sketch here, which has to be adjusted. I'm going to edit the sketch. Notice everything moves. I'm going to do this by hand, or more or less by hand. Turn on analysis. the inside radius of that guy. 12.5 bar known as a diameter, 25. So let's start dimensioning this. Escape wants to get out of the dimensioning tool, pick that. 15, so 30. And again, as we do this, yeah, we can use parameters for this, of course, but for now, to save some time and to continue making the point, 17.5 times 2, 35. So I can't do math anymore. And then last, 30. That's not what I wanted. Get out of the. I picked up. I was doing a projection there. 30. This is just my habit. I like to put it right underneath where it is. It doesn't really matter. And once we're done, say okay. Make sure everything's good. Perfect. Now, there is a choice here. I am gonna do a couple of things, strangely perhaps. I'm gonna do the cutouts in the shaft on this sketch. So chamfers and ring grooves and such. I'm gonna do a separate sketch for the, what inevitably is coming is the keyways. So while I'm here, gonna finish the sketch, pull back all the way, put a new sketch in here on the same phase, and just put a little memory thing in here. So I'm gonna put in a slot center, no, overall slot, that's how they're measured. And don't care right now what it is, finish the sketch. Call it layout, say cuts. Hide that. Notice it's unconstrained. All the rest, the same with our bigger sketch. Why? Because of that shoulder in there. So we'll just keep that in our back pocket for now and work our way along to the end. Now, there's going to be quite a lot of stuff going on in this. We end up with quite a large history, unfortunately. It's not much we can do. Everyone's looking okay though. So let's go ahead here and fix up the chamfer at the end. It'll give us an idea how to do this. Edit the sketch. Now you'll notice everything jumps around when we do that because of where the sketch is, right before the joints. It's a little painful, it's not bad though. So let's go ahead here and give it a line tool at, say, 45. This is quite big, of course. So we're going to have another one at the far end. So let's do another line. Snap it in here. And we can do this kind of all at once without doing too much. If it's at 45, we can use perpendicular. And we can also use equal if we're going to make them both the same, which we probably should. Dimension this guy, just pick the line itself. Oh, make sure you're way, there's there's three options. The length of the line, the projection of the line vertically, and the projection of the line, if I can get it the other way, go, there it is, there we go. Doesn't matter which one you pick, but to put it near the angle, let's go for say 2 right now. Notice they're both defined. Last thing that we have to do is figure out where this shoulder's sitting. Now, I'm going to say something here that the purists or from whatever industry might shout at me and want to have me pulled out into the street. Some people advise Shigley seems, we use Shigley for architects here in the class, and Orlov. Both of them seem to kind of imply that 120% for each shoulder, so 20% more. So what does that mean? Well, 30, if we have 30, and then we say, well, times 1.2, 36, we have 35, it's close. 25, say, is 30. So we see a natural progression here. given that, I'm going to take the larger of these two, 30, 35. I'm going to go for 42. It's not bad if we look at this. See, this gear actually has a very small chamfer. Both of them are from KHK. So we actually are going to end up with probably a sharp fillet on everything here. We won't be able to fit a well-rounded under this. So we have quite a tight fillet coming. So this is not too bad, actually. We could probably get away with this. We'll see how it goes. The advantage of using a lower shoulder is we start with a smaller blank, which saves a lot of material, machining-wise. So this is good. You want to keep the shoulder as low as we can, and since we do have really tight chamfers on these gears, that seems to be good for us. So let's stick with that for now. One small detail to look at here. If we look at this, we'll notice right now, even when it tightens up the mesh inside the parts, you'll notice we've got a bit of overlap. This is because I didn't place the part perfectly. So it's not an error. It's just the placement is not done because the joints haven't activated yet. Finish the sketch and it'll jump to it. Perfect. There we are. Our components are placed and our shaft is shaped. One thing missing is the chamfer. The easy way to fix this, just select this thing. Profile, you'll notice has added the two little triangular profiles. Just X that thing and re-add it. Say okay. That should not cause any errors, but it does activate the chamfers. Perfect. There we go. That's our shaft shaped. Next is going to be, I'm going to stop this video here. We're going to do another video for the ring grooves to hold the components in place and the standards driven keyways and keys underneath these two gears. We'll download everything we can from McMaster Car. At the end, we'll do a little bit of a jiggle to figure out what is a good length, because right now this looks like it's sticking out a little far. So we'll maybe readjust or adjust these lengths under the bearings. It sticks out maybe too far. So that's the next video. So thanks for watching, and we'll see you in the next one.